Getting into VNets a little bit more. Um, when I first started working on Azure, I started creating VNet peerings because that's just a natural thing that happens.
Yep.
And you know, as you add more and you try to create a full mesh, you can quickly that can spin out of control.
Yeah, you end up with a spaghetti plate.
Exactly. And sometimes we don't want the spaghetti plate. I mean, I like that for dinner, but maybe not for my network. Is there anything new that's been introduced that can help with reducing the number of peering connections while still maintaining that full connectivity between VNets?
Network peering, in my view, is only there to avoid having to deploy VPN gateways to connect every other network that you have. I see it, and I've always seen that cloud computing or cloud networking is an extension of the physical that we've been dealing with for years. The concepts are pretty much the same. The implementation of them is different. So when you're looking at, I'd say, a physical environment, I take a company X that has offices in multiple buildings or multiple cities, but they all need to access the same central HQ for the HR database or the corporate workload that needs to happen. And you have those individual network that are supporting branch offices, and then you have to connect them somehow to that head office. That's the same when you end up in cloud. So you have your VNet in region A to support, and I like to personally, I like to when I design or I help design infrastructure to support workloads, to group everything that has the same life cycle. So that follows the application life cycle. So if it's supporting workload A and workload A is being turned off or because we've migrated to something else, all of that goes into the same resource group because the resource group are just logical containers. And then I have my virtual network to support that workload.
Hmm.
And that's it. I don't have a virtual network to support multiple workloads because then it becomes too complicated when you try to filter. You end up with going from point A to point B, having to go through 100 different NSGs. And if your connection breaks, which one is it? The one at the NIC? Is it the one at the VM? Is it the one at the subnet? Is it the one on the other subnet? Is it the one like? There's too many points where it can affect in between.
Well, is there a design concept where if you take a bunch of VNets that you need to talk and you don't want the spaghetti plate, you make a hub and spoke topology out of it, something like that?
Yeah, that's what we have. That's what virtual WAN is.
Oh, interesting.
So
When I was first introduced to the concept of virtual WAN, it sounded like more of an SD-WAN play where, oh, I've got these SD-WAN appliances at my branch offices and I want them all to hook into Azure, so I'll use virtual WAN. But you're saying that's
it's
maybe
both.
that's a use case. But
It's
it
both.
could also apply to, how does that work with the VNets then? Does it use the peering connection or do you have to set up VPN gateways on every VNet?
So virtual WAN is basically the architecture, the hub and spoke you just mentioned.
Hmm.
Okay.
That's what its main function is, and you can connect VPN devices to it. And I'm looking at my list to make sure I don't forget any. Uh, uh, um, private, so point to site VPN to it. So your customers, no, your customers, your people that are working at home now because of this age of the human malware, and you don't have VPN concentrators everywhere. So you get them to connect to the WAN, to the virtual WAN, and then from there they can connect to every other resource that is connected to that virtual WAN. So whether it's a VPN or other SD-WAN device, so software defined a networking device, users, whether they're Azure VPN, OpenVPN, anything that basically is IKv2 client type. Of course, there are some that are not supported, but we're not going to jump into that because then I will definitely lose my job. Express route circuits or virtual networks, either in a peered or VPN gateway connected capacity. So you end up with that hub and spoke as opposed to have VNet A connected to VNet B and VNet B connected to VNet C and VNet C connected to B and A, and then you end up with that spaghetti.
Mm-hmm.
And every time you deploy a new site or virtual network or a workload that has its own VNet, and it's I need to talk to this database was over there, so you have to connect to this. Oh, and because of the monitoring, you have to connect to this. And then, so for every one you deploy, you end up having to put like 10 more connections, and most of those connections are bidirectional. So you have to set 10 connections at 20 different endpoints.
Right. So yeah, you go with that hub and spoke type architecture. Is the gate the virtual WAN limited to one region, or can you plumb in stuff from other regions?
It's global. You
It's
can have it global. Yeah,
Oh, wow.
It basically uses our own backbone.
Okay.
So the private fiber that we own and in most cases have laid down ourselves to connect all of our network or data centers worldwide. When you're looking at virtual WAN, you are using that fiber and not public utilities or public internet. So there's a bit more resiliency there because it's under control. We're not relying on AT&T and Bell Canada and I don't know what the rest of the Americas or Europe are using in terms of telcos, but you know what I mean? Like we don't have to worry about utility internet connections. It's our own fiber, and that virtual WAN is on that fiber.
Interesting. So if I had an express route circuit in the US and one over in Europe, I could use both of those express routes for my local offices there to hook into virtual WAN, and then I'm riding the Microsoft backbone across the Atlantic. I don't have to, worry about the vagaries of the internet and internet providers.
Yep, exactly.
Which is not the way all the cloud providers work, Ned, as I understand it. It depends on which cloud provider. Everybody's got fiber all over the world, but not everybody wants you on that fiber all the time. They'll maybe punch you to the internet quickly if they can.
Some of them will make you pay for that privilege quite dearly.
And you are paying for it. So virtual WAN is not a free product.
Right. Okay. So there's a cost associated with it.
So there's in the Azure networking, there's always a cost for egress, unless it's within a region. If it's not leaving the region, then so you're copying from server A to server B within the same region, you're good.
Okay.
If copying from server A to server B in a different region, then you're playing ingress on server B.
Right.
No.
Okay. Egress
on server, yeah.
Server A. Okay. Yeah, that makes sense.
Basically, everything coming in is free. Everything coming out, you pay for.